So welcome to another episode of the Combines and Coffee podcast. We are here today in Kitchener, Waterloo with Lori Phillips, Chuck Baresich, and Xavier or Xavier?
Either way works.
Okay,
exactly.
Xavier Hébert?
Yep.
Perfect. Just finished an amazing session on New Frontiers here at the Innovative Farmers Association conference. We're just going to have some nice, fun, candid conversations. Really excited to be chatting with you guys. It sounds like everyone else is equally excited to be chatting with you guys. I'd love to start just a brief introduction for each of you and tell me a little bit about what you guys were talking about today, especially for those who are tuning in at home and are entirely sure what was spoken about. Lori, we'll start with you.
Right. So I work in soil microbiology, and we were talking about what happens when you transition your system from basically a conventional system to a perennial cover cropping system. Can we actually detect what changes happen below ground? What are the changes? What direction are things going? What's improving? What's not improving? And how do we detect those changes more importantly as well? What are some of the new tools that we have in our pocket to actually evaluate what those changes are?
Very cool. Awesome. Chuck.
Our agronomy company, which has been involved in precision agriculture work for close to 20 years, starting in 2020, we ventured into agricultural robotics. So what I talked about was what that transition looked like, some of the challenges that we had, and I gave it, an example of some of the pieces of tech that we're using and why we're using them and why we think that there's going to be a place for this technology moving into the future.
Amazing. Thank you. Xavier.
Yeah, so we're talking about what Picketa Systems does, and we're working to make plant tissue analysis happen in real time in farms right there, so you can see your full nutrient profile, be able to dose your fertilizers, and specifically going over an interesting project we started with the University of Guelph, expanding different crops from potatoes, corn to onions, and now adding even more. So had great conversation with growers and got even more suggestion on new crops to add to the platform. So it's been great.
Amazing. One thing I find really interesting about the IFAO conference is you have this clear difference between like big I innovation and small I innovation. We've had some great discussions with small I, but not a lot with big I. And I think that's what makes you guys so unique and really cool to speak with. And considering each of your unique focuses, soil biology, agricultural robotics, and nitrogen management, how do you see these disciplines intersecting to shape the future of sustainable farming practices? And whoever wants to answer, I'll just open the floor.
I don't mind starting on that one. I think the technology and the ideas, like we're at a unique space in time where there is a convergence of the technology, and really we're trying to take crops and crop production, to the next level. And when you think about, what stage that agriculture is in, as we move from basic, agrarian, you settle down, you start farming, you move through the, kind of the industrial revolution of farming, the invention of nitrogen fertilizer. Then we move into chemical farming. We move into big technology, like big tractors, equipment, and all these kinds of things. All of those stages have taken us to a certain point on the productivity curve, but I think that's leveling out to some degree. And now we're looking to what is the next piece of tech that's going to increase that. So what we've done to date has taken us so far. Now we want to move past that.
Very cool.
It's interesting you say that, because in some ways when we're looking at soil biology, we're going back to practices that were used 200, 300, 400, 2,000 years ago, where, farmers knew that if you continually planted the same crop in the same spot, that you would have disease problems, your crops wouldn't grow as well. So if you're going to grow corn, you should probably throw a bean in there as well. You look at indigenous cultures, you look at, historically through the record. I mean, that was common knowledge back then. I think the difference now is, and again, I agree that we're plateauing, and now we're both looking to the past and looking to the future to see how can we make that next great big, that next leap, that next increment. And I think we really are working, and when you're looking at biological systems, we're not talking about fundamentally changing anything. We're talking about small tweaks. What are those small tweaks that we can use using, deploying new tools to assess questions that are thousands of years old to understand what exactly is happening when you do this. And with that additional information, you can maybe make that additional small step going forward. So it's an interesting divergence, I would say, and convergence of disciplines and knowledge.
Very cool.
Yeah, I think Chuck really had a great point on his presentation where it was, 2 + 2 = 5. How can we find that? And when you look at kind of a new sector coming in for precision application, new ways to measure things, apply things, that's where things are headed, right? Everyone's kind of proven their own path, but once you start thinking of how things connect together, into a new system, that's pretty interesting to see, and you're starting to see little hints of it here and there. So,
stuff that people did, like as you said, 300 or 400 years ago, that we excluded out of the system because we wanted to use, because some other piece of shiny tech took us a certain way. Right. Now we can bring that back in, and again to get to that 2 + 2 = 5, right?
I agree. What was interesting to me, and this may be a bit of a digression, but you were talking about how your system can be used to detect disease loads as well. So, I mean, if, again, you're looking at subcellular, basically, changes in plant structure that are indicative of that disease taking hold, but you could probably take that same information, apply it to things like, is my legume, has it inoculated properly? Is it fixing enough nitrogen? Or should I be looking at modifying the way I grow my legume crop so that I can get better nitrogen fixation happening through that biological plant symbiosis, but using a system like yours to detect where those deficiencies are happening, rather than having to go in with a shovel and dig something up and crack open a nodule and say, oh yes, look, there's something there. So I think there's some interesting convergences that can happen from the biological perspective and the technological perspective on farm itself that can be quite advantageous.
And we can do that at scale. And we can use a sensor like this, and we can do, instead of just doing one shovelful and saying, well, that's representative of the field, which doesn't get us anywhere, we can now do this at scale in real time. That's the cool part of this, right?
We'll mention the virus detection is in R&D, but even with the nutrients, right, you can make sure that you're as resistant to disease as possible. But fully agree. Once you have the access to the crop and you're already scanning it, what else can you do with that?
So you've already built us the tricorder from Star Trek. All right, that's awesome.
That at scale piece applies to soil biology as well. I mean, the only reason we can do what we do now is because we have higher throughput methods. So the prices have come down for the technology because we piggybacked on the medical world. Prices have come down for the technology. High throughput as we get more and more, we get better equipment in the labs, we can do more and more samples, so we can start high throughputing those assays. But right now, like from my perspective, the bottleneck for me, a lot of it is still actually physically getting a sample and getting a sample that's representative of the field. So we take as many samples as we can, but there's a finite number of shovelfuls of soil that you can bring back to the lab and analyze. But if you can use the instrumentation to determine where are the good growing areas and the bad growing areas, to simplify it, and then use that instrumentation to determine a sampling strategy to go in and look and see what is deficient or advantageous in the biological community, then you can start to upscale what we're doing as well using these new technologies.
Yeah, cool. Like what Farmer said it in the breakout session there, if you have it, you're going to use it, right? And when it's accessible there, it makes it so that some practices that were maybe would only make sense in vineyards or potatoes or very highly managed crops are now possible to do with corn. And just, how the metrics on hand changes what you pay attention to and then what you're managing, right? So, we're not the only ones doing this. There's a lot of other layers going on, and, once you have that data, how do you apply it? But that's about where you're getting afterwards, right? Yeah.
Cool. Would you guys be able to discuss the specific challenges within modern agriculture that each of your areas of expertise are addressing? Xavier, why don't we start with you?
Yeah, I think like Laura mentioned, data availability and scalability of data. A lot of the advice, a lot of the way agriculture has been done has been on kind of relying on human senses for a good while, and we're getting more and more kind of quantified. But this would be like another step where you can see the full nutrient availability there. So that's the first one, and then goes into other things like labor availability with being able to cover more ground and things like that.
Very cool.
but the first one's data, knowing what the crop needs. So
And labor availability, it's come up a few times today, and I feel like it's going to keep coming up. Chuck.
I think the labor is one, and as I mentioned in my presentation, it's not just labor cost; it's also the opportunity cost or what's lost of not getting that labor. The cost of not having the work done on time. There's when we look at weed control, and a lot of the focus of the robotics is on the removal of weeds. There's a lot of crop loss due to weed competition that just isn't being measured right now, and it's just an accepted farming practice. That the weeds have gotten big, it impacts the crop. Who knows what else is impacting on the crop physiology? So the use of robotics can help to alleviate those two pieces. The other thing that robotic systems can do is they can add a layer that they can help to manage the complexity of the operation. There's so much going on in a crop or in a field. We haven't 100% figured out that space yet, but the idea of using the sensors and cameras and things is we can start to measure this technology at scale and hopefully turn that into something useful. And I don't want to sound like that's not there today. Like there's lots of promises being made, but that is one of the outcomes that we hope to get. 100 years ago or 200 years ago, or when a farmer farmed, they would grow a crop on a very specific part of their field because they knew it would perform well.
It did well there.
But that practice has gone away. One of the promises of tech is to sort of figure out why that is, and to allow the machinery to go back to matching the crop to the farm and try to get back more in a better rhythm or cycle or whatever. And that's what we're hoping for.
Glory.
It's an interesting question when you're talking about soil biology, because I think it's, to a certain extent, it's a bit of a luxury.
Right.
It's that value added that once everything else is normal within the system. But on the other hand, I mean, I'm in the business of providing knowledge. That's what I do and that's what soil biology does, is it provides knowledge about how your system is working. So you can manage that system from the surface, and we do that. That's how we farm, typically, is we manage it from the surface. But if you don't know how the engine of that system is working, I mean, the biological processes are the engine of that system. If you don't know how the engine of the system is working, there's only so much you can do to keep the system running. And I think the one thing that, our advanced understanding of soil biological processes and the tools that we have to measure those processes is providing that knowledge that allows you to make, again, we're talking small tweaks to the system to see, to improve those yields just a little bit, or to say, why isn't this marginal area working for me? Because it might not just be a question of it needs more boron or it needs more nitrogen. There might be something fundamentally wrong within that system. So we do layer in and add value, I would say, but we're not a fundamental driver of increased productivity in and of itself, the tools that we bring to the table.
In some examples that I've seen, when we're bringing in cover crops, let's say into the horticulture space, that the introduction of cover crops into an area of the field that was normally bare, it can in some cases help to alleviate other stresses. It can provide competition for insects. It can provide other benefits that in the past, because the farmers couldn't manage those areas any other way, they kind of ignored that. And so there's a lot of this, farming at the surface level can only take us so far. And that's a great way to put that. I like that. I'm going to steal that line, actually. Yeah.
Speaking of lines, actually, something I've heard a lot today, and especially over the past few months, is like the saying where we know more about like the stars in the sky than we do what's going on like 7 feet below us. Can you guys speak to that and tell us, is there some truth to that?
Probably. I mean, it's hard, right, to look below the ground. I mean, when we're looking at the stars, we're using equipment, telescopes that are capable of scanning immense distances and time with distance. When you're looking below ground, the only way to truly understand what's happening below ground right now is to dig a pit, is to take a soil sample, is to take those soil cores. So the work of looking below ground is still quite labor intensive, and because it's labor intensive, we don't do as much of those surveys as we used to. When it comes to looking at the biological communities, I mean, realistically, we've only had these tools at our disposal for 30 years. So, we know more about what we don't know now than we,
There's even more questions.
Exactly. So some of it is access to tools, some of it is labor intensive. There's some interesting work going on that I'd like to see continued with using LiDAR imaging to, they're using it to map cover crop coverage. They're using it for soil moisture. And what we'd like to see happening is can we actually use that to map areas that might be deficient in certain microbes, for example, nitrifiers, denitrifiers, or whatever. So we've done some work with mapping at a central experimental farm in Ottawa, trying to see can we actually start predicting what we would expect to see from a biological response based on these variables that we can detect using remote sensing. So really when it comes to how much we don't know below ground, it's because of the tools and the labor. And we go back to tools and labor, which was mentioned earlier, and there's only so much that we can do at any point in time. That's really, I don't know if that's,
I think that was great. And then you guys looked at
Pretty much covers it.
I think, if I put my farmer hat on, we've always taken the dirt for granted. We called it dirt, right? And so if you needed to move the dirt, you dug it and you threw it away. If you needed to bury your garbage and make a big garbage dump somewhere, you dug a big hole and you bury, and that's, we have not put the value on the soil as we have on other commodities and other things. And we it's just so ubiquitous, it gets ignored. And I think that's partially the reason. The other reason is that it's always treated us so well. So the fact that we have just been able to do whatever we wanted to, it hasn't come back to, and it's interesting when you see the extremists, there are some extremists that come out there and say we only have 7 crops left. 7 crops and the soil is depleted forever. Those people they're not helping us.
it's like an interstellar type dystopian future.
But on the flip side, the practices that we're doing today, treating the soil as we have, as you have mentioned, what we can get out of that has plateaued. And I think this is why it's coming of interest now.
Yeah. Kind of reached the limit, so now you're like looking underneath and looking at the code and seeing how can you go deeper.
Well, I also think, I mentioned earlier that it's a luxury to be able to look at the soil biology. And I think, if you look at Canada, Europe, the US, we are countries that are relatively food rich, right? Yes, the soil is degrading and there's no issue.
And cheap.
And it's cheap.
Yeah.
But we haven't had to worry. We haven't been at the edge of sustainability. If you look at other countries where productivity is really, really low and where people are living at the edge of sustainability, I think there's a little bit more probably individuals there that are paying a little bit more attention. Because they have to. The biology is something.
100%.
Understanding that the biology is critical to survival. Whereas here we haven't had to. It's kind of like me and the Mini Cooper I drive. I mean, when I drove an old beater pickup truck, I was changing the oil every two or 3 months because the metal filings were adding. But when I'm driving my Mini Cooper, I take it in once a year. I don't have to worry about the oil. So yeah, I think our soil here, like you say, we've taken it for granted.
It's more of a food waste issue.
We haven't had to worry about it, but now we're realizing 2 things, both that our soils are degrading, and we see that really, really clearly. So our soils are degrading from a biodiversity and from a nutrient perspective in general, organic matter. And we're also, again, where we know that we need to feed, that many more people in the next 20 years. So we have this paradigm where the resource that we need to feed those people is degrading, but the need for food is increasing. And the only way to bridge that gap is to start taking care of that engine that's driving that system a little bit better.
And those are data-driven.
Yeah, those are data-driven decisions.
Right.
Yeah.
And on that note, Xavier, I'd like to loop you in here. So your work focuses on making nitrogen management more efficient, correct?
Yep.
Okay, perfect. Just want to make sure. How can data from soil biology studies and robotics technology inform and refine nitrogen management strategies?
Yeah, I think it's key. Like whenever we work with any agronomists, like you're looking at the soil maps, you're looking at weather, and then you're looking at leaf tissue, right? It's about having all that data in context, because without that, you're not knowing, is it a lack of a nutrient or is it just the availability of it, right? A lot of it is determined by the soil biology and what's going on there, right? So leaf tissue is one part of it. It's one part of it that was inaccessible largely for a lot of farmers, for a lot of crops, due to having to go through this chemical process and having it ground up, sent out, shipped and labeled and all that. So yeah, it takes, still takes the agronomist to know that region, know that farmer, and take that data and do recommendations for it. Like they're the one who act on it and then do the best for their crop. Yeah, with the automation part, that's super exciting and something I hope we continue to work on as we're working with Guelph here and with Chuck there as well. Is how can we take the system, which right now it's still a scout going out, picking leaves and scanning them. What's the next evolution of that? Like having it done as you go. That's kind of the holy grail we're working towards. I'm sure there's lots of work to be done there to make it possible, but does it take too much imagination to see this being done continuously, as looking at every leaf, looking at every crop as machinery goes down the field? So, and that makes it a lot more possible with autonomous vehicles and precision application methods.
Very cool. Is there anything you guys would like to add?
Can I tell you what my ideal robot would be? So my ideal robot would have the capacity that your system has for scanning leaf tissue to detect whether it's nutrient deficiency or disease symptoms. And it's being carried by a robot that doesn't zap weeds, but that actually will be able to take a soil sample or a plant sample, put it into a carrier, we can bring it back, that comes back in, goes into a lab system that's all coordinated as well, and we can detect if there's disease, if it looks like there's disease pressure, what is the pathogen? What's the pathogen that's colonizing the root? And can we actually marry that up? If there's nutrient deficiency, can we target and see, are there certain organisms that should be present there that aren't present there? Then the robot comes back in with a bioinoculant and sprays those areas where nutrient deficiency is occurring, where microbes, biological solutions can actually play a role. And that sounds far-fetched, but from the technology, it's not. And we know that, there are people that are working with target foliar inoculants, for example. So if you could go in and rather than doing a foliar inoculant spray across the whole field, use this merge system and understand the biology of it well enough that you could go back in and say, all right, here's the solution for this in real time within the space of a couple of days. I mean, that to me would be an ideal merging of all three kind of technologies that we're talking about.
So one of the dangers of giving farmers a little bit of data is once they have a little bit, suddenly they want everything.
What is it if you give a moose a muffin? Yeah.
Right. And so the technology that we have now, we have the ability to generate that data. And what we're seeing from farmers' yield maps and from soil test data and all this kind of stuff is that our old ways of understanding what's going on in the field just don't cut it. In that the yield responses to what we've always done, because the farmers generally, their default position is, this is what I did last year, so I'm going to do that next year. Which is, and and it works for them. I'm not cutting the farmer up. The reason why they do that is that it generally works. And, farmers aren't dumb people. But what we're seeing is that the soil testing done the way that we have been doing it is not equating to the outcomes, and they're not matching up, which is why we're sitting there saying there's something else going on in that soil. And what is that? And then your sensor hopefully would tell us, is it nutrient related? Is it disease related? This is where this comes from. Where the technology merges together is in the generation of an actionable item to the producer. The producer actually doesn't care about the soil test readings. The producer doesn't care about the nutrient read. They don't care about any of these things. The producer cares about what should I do? And this is where it comes into generating a map. And one of the reasons why, if I put my agronomy company hat back on, I get pitched close to once a week by a company who has a new product, and we can call it voodoo juice and snake oil and all these kinds of things, okay? For the most part, these products in the lab show promise, but in the field, they very rarely work. And the reason why they very rarely work is that we don't understand what is going on in the soil. And if we could apply those products to the areas that need it, we'd probably have a lot greater success rate. And this is where the convergence of the tech starts to come together, where we say, let's match the product to where it's needed to get the result. And a good example of that is we've been trying to do some work with, fungicide trials in soybeans, targeting that fungicide to the parts of the field that actually need it. And this is where the potential of drones comes in.
Right.
The spot application. It's where this is going.
I'm sure that was in Blade Runner. In Blade Runner had a scene.
Yep.
Something similar.
Well, there's a lot of like dark matter, right? Like,
100%.
Interesting.
which is, in astrophysics, if the equation doesn't work out, there's some
dark matter.
some type of dark matter working out, but the reason that is that the more you know, the more you don't know, right? So kind of looking at
In soil biology, we call it the black box.
Yep.
It's like we know something's happening in that black box, but we don't know what it is.
It was the previous farm owner that did it.
that just haunted,
Yeah.
I'd like to take a bit of a pivot, but I think this will have a little bit of fun here. So Tori, wonderful, amazing executive director for the OSM, the IFA, was telling me a story about Chuck and Chuck's family. I learned that your family has this annual tradition where one member gets to choose an activity during the week, fostering, a rich environment to explore, create, be curious together, and really explore that curiosity, which I think is such an important part of innovating. So this tradition has sparked an interest in engineering for your daughter, correct? So this is highlighting the importance of exposure and support in shaping the aspirations for young women, especially in agriculture. So in this agricultural context, specifically ag engineering, a field where women are increasingly making their mark, as we have the amazing Lori Phillips with us. Can you share how this inclusive family environment has influenced your view on diversity and inclusion within the agricultural sector, particularly regarding the role of women?
I think from my perspective, growing up in a very traditional, farming background, the way that things were done was that when you needed workers, you went and you found the farmer's son. That's who you hired. And the way that jobs were structured were all kind of around that. You hired that person because you knew that they grew up driving that tractor, and so or driving that sprayer, and because that's what they did, you had confidence that if I bought a brand new $700,000 sprayer, if I hired that kid, they could operate it. That's kind of how things were done. The reality is that agriculture is such a small community nowadays. If you still have that mindset, you are going to have no workers, and you have to open your world up, that it's anybody who has the interest. It's the interest and the attitude you need to hire for now, not necessarily the background.
Interesting.
So this includes not just farm kids, but people who are outside of agriculture who really want to be in the space. And it's interesting that the technology sector somewhat helps to bridge that gap, because it provides a connection that's outside of the traditional roles. And when we're looking at our business, we look at this now, that are there things that we could do to alleviate some of those barriers? And I guess one of the examples that I think about in my own life, like one of my daughters would like to join us in the family business. She's interested in this. She comes to all of our robotics conferences. She's very much part of this. But there are certain things that physically she's not strong enough to do. And the old way of thinking was we used to kind of make fun of my sister, not strong enough, and
right.
But you don't think about at the time how that actually creates an exclusionary environment for her to be part of that. The way that I think about it now that I've grown up and matured, is how do I change that system so that she can participate, so that she can be part of it? What jobs, how do we structure this? And so my daughter, for example, she drives our irrigator, spreads all the fertilizer, does all that kind of stuff. this is something that she can do and she enjoys doing, and then being in the space, it's actually fun to watch her interacting with potential customers and things, and them coming up and asking her questions and stuff like that. And it really is a change in mindset. The skills that people can bring to the table are more than just a strong back and weak mind kind of thing. It's the technology skills, the interpersonal skills, the way of thinking about things in a different way. That's what we're seeing.
Very cool. Lori, just some thoughts.
I mean, it's interesting you talk about trying to improve representation within whatever the workforce is, and agriculture, as you mentioned, has traditionally been male-dominated. And I go back to my childhood, and I grew up in a small farming community north of Edmonton. And we were it was a small town. There were a lot of farm kids. There was a lot of non-farm kids. In that scenario, the guys in my class who were from farming families were the ones that were doing the heavy chores, whereas the girls in those families and those farming families were the ones that were getting up and helping their moms get the lunches ready for the guys going out and do the chores. So I saw that division really, really clearly when I was growing up. What changes a lot is also is increasing representation. So in your daughter, other women will see your daughter. They'll see her in that role. They'll understand that there are possibilities there. And if I can draw a parallel to my own career, I suppose, I had no idea that a career like science was possible when I was growing up. It wasn't on my radar. I didn't know any scientists. I certainly didn't know any female scientists. I watched David Suzuki on television. That was it. That's what a scientist was.
Yeah.
It was only when I started, exploring and getting out of that small town, I started seeing those role models who were doing science, that I realized, hey, this is a career. I can do this. I am welcome in this space. So I'm welcome in this space. I'm capable of working in this space. And it's a space that's going to be welcoming. Like I say, I'm repeating myself there. So I think that representation that you're talking about, removing those barriers for people to join whatever that working environment is, and then having that person be, again, they will influence 2, 3, 4, 5, however many more people to join in that environment. Because again, representation really does matter. You need to be able to see yourself somewhere.
And she still gets lots of double takes when she's going down the road in the interrogator, and people look and say, who's driving this thing? But I look at the example of if drones ever become legal for spraying, for example, not very many people would feel comfortable driving a $500,000 machine at 30 miles an hour, hurtling down a side road full of chemicals. Not a lot of people have that skill set, but a lot of people have the skill set of operating a small drone,
right?
Using a small jug to fill it. It's just a regular vehicle goes down. They're still doing a farming job. And it might look a little bit different, but they're still doing that same job. And it opens up the labor pool so much bigger than our traditional old view set of what that was.
And when you're going after big challenges, like we talked about, of going deeper on the science side, that attracts even more talent, right? Like if you feel like you're contributing to something. And anecdotally, going to the conference yesterday on the bus, I was sitting next to someone who saw me working on slides and said, I've never worked in agriculture. I've worked as a PhD in psychology. I find this interesting, and I want to work with robotics and technologies and things like this. And this was, there were still those, she even asked, will people accept me? There were still concerns, but things like this, things like showing the science and technology side I feel is going in the right direction to attract people. It was good to see someone from Toronto go out and come to Kitchener, come to Guelph to see this type of things going on.
Two of our employees are not farm kids.
Yep.
But they want to be involved in ag, but they came from the tech side, right? And it's fun to see.
Yep.
I would say almost 100% of the students that we have coming through the lab have never set foot on a farm before. They're always very excited to see their first chicken. Drive down the road heading towards the field site, and chickens are, it's like spotting, moose in the wild or sort of thing. So when you're looking at, again, for me, providing that access to these. Most of these kids are coming from the GTA. We hire from Waterloo. We hire from Guelph. We get about, a stream of co-op students coming through the lab. One of the things that they learn is that farms aren't scary, right? I mean, I know the machinery is scary, but one of the things they learn is that you can apply logic and reason. It's not all about brute force. You can go in and you can see the elegance of the system. You could see the elegance of the solutions that people are applying to manage different problems, regardless of what those problems are. And by bringing those kids through the lab, and they're not flowing necessarily to farming systems, but they're taking that knowledge back home with them. They all interact with some of the farmers that we work with. They usually get rides in combines and things like that, which is always very, very exciting. But they take that knowledge back with them, and so you expand an awareness and a knowledge of what farming means today in a group of individuals who would otherwise not have any access to that information. And I think when you're looking at expanding the talent pool, that's equally important to consider sort of the peripheral activities associated with farming, where you're giving people experiences who wouldn't normally have those experiences, and then they take those and again they disseminate it to the wider community. And I think it brings more people in. I really do. So I mean, we've seen a lot of the students that have come through the lab go into grad studies, and students that never set foot out of Mississauga are all of a sudden doing a master's degree in plant biology at UBC or something.
All they know is the parking lots of Square One.
Exactly. Yeah. So I think that there's different ways of bringing people in and of increasing that representation and increasing that potential labor pool as well.
And we need it.
Yeah, we do.
And we need it. We 100% need it.
Yeah.
Well, everyone, this has been a truly fulfilling conversation. I want to be very respectful of your time, but I also want to give you guys the opportunity to share with our audience any final thoughts, something cool that you're working on that you think the world needs to know about, or just any personal stories. The floor is yours. Who would like to go first?
Can go first. Yeah. The main thing I'd mention is anyone listening to this who conducts a lot of tissue tests and would like to see a different way of doing things, please reach out. We're fully commercial with potatoes and corn right now, adding onions, canola, and looking to be in every crop eventually. So yeah, we have stations available, and hopefully we can reach a wider amount of people here. So
amazing. Awesome.
I think from our standpoint, we're always looking for people to collaborate with, both people to join our autonomous working group. So we're looking for farmer representatives to join. We meet every Friday morning, so people want to know more about what's going on in the automation sector. And then we're very excited to be launching our Innovation Farm Network, as I mentioned earlier, and people want to know more about that. It is a work in progress. We're figuring this out as we go, but we're very excited about this project for the next 5 years.
Amazing. Thank you.
I guess I'd probably like to end on the fact that I mentioned the black box of soil biology, and one of the things that's happened is that we know a lot more about what's happening below ground, and the good news is that the below ground ecology functions much in the same way as the above ground ecology, and we can make sense of it. We can understand why things are happening. We can understand cause and effect. We have the tools with which to detect the cause and effect, and we have the increased knowledge base to start to make sense of why the system is behaving the way it is. So it is a logical system, it's a living system, and we are beginning to understand exactly how the different farming activities alter that system for good and for bad. So it's no longer that dark matter or that black box that we really are making. It may not seem like it sometimes from the outside, but we really are making great strides in understanding the engine that's driving the farm.
It's incredible. I'm so upset that dinner is being served right now. I feel like I've been chatting with you guys all day. Like, genuinely a wonderful, fulfilling conversation. So happy to have you guys on the show. Everyone tuning in at home, thank you so much for watching. We have Lori, Chuck, and Xavier. Their information, all their contact information will be in the bio, the description below. And once again, thank you guys so much.
It was a pleasure. Thanks, you guys.
Yeah.
Thank you.